Hi, everyone. Good day to all. This webinar will be about SLA compliance through synthetic monitoring. Today's agenda looks a little bit like this and will take about 35 to 45 minutes. We'll start with a quick intro on speakers, and our partnership between the companies. Then really a frame of why SLA compliance is important in today's sort of high stress environments, technology environments. This is then followed by a deeper dive into the what, how, and best practices of service level agreements and its importance. Now, let's start with a quick intro. My name is David, and I'm responsible for the global relationships with ITRS partners, specifically technology partners we integrate and offer commercially to our customers. The partnership with Apica strengthened, complements, and expanded ITRS offerings in synthetic monitoring, which helped shape our business strategy, ITRS's business strategy, and go to market. Over to Troy Presley, who is Apica's synthetic monitoring product manager. Troy.
Hi, everybody. I appreciate you joining us today. As David said, my name is Troy Presley, and I'm the product manager of Apica's synthetic monitoring product. And I'm very happy to have this partnership with ITRS. As we'll go into later on in this presentation, Apica's synthetic monitoring product has been used in the financial industry and other industries with sensitivity on monitoring. And I think this partnership will bring a lot of value to a lot of different people.
Thanks, Troy. Now some quick slides about ITRS before I hand it back over to Troy again. So there's some stats on the slides, but the key takeaways are ITRS, has been, a long-term FSI vendor pedigree. The key business strategy over the past year and a half, in fact, was to build, buddy, and buy. We've built a key repository. We've budded with 3 strategic partners of products, Apica being one of them, that we resell to our customers, and also bought 2 strategic companies focusing on rounding out our capabilities and expanding our go-to-market industries. We're really seeing some strong traction of our business strategy with both FSI and beyond. The financial services industry obviously is a pedigree, but also beyond that. And the product strategy that underpins this business strategy is going to be covered on the next slide, which is what we call the production tools landscape. So the world of running production is really knowing what's going on in your estate. You've got servers, you've got networks, you've got storage, applications, software you've written, running, and essentially you need a monitoring solution to watch all that estate and give you visibility and observability when things are not how you want them to be. Many tools can do that, obviously. We are certainly one of them. And have our own tool set. However, we really advocate that you should bring and integrate all your tools to a single console. Understanding what it feels like to be a customer of your infrastructure is also key. If you deliver service, to external clients, having a view and observability of end user experience is paramount. It is easy to be blindsided by issues with your firewall or connectivity to your internet, ISPs, mobile experience versus browser experience, and even generally being able to test the performance of your applications with synthetic tests, which you're firing up and running against your applications. Another one of the tools to know what's going on is inside the app monitoring. Whilst you see other tools there, right? We are trying to give context for our tools in the broader context of the other tools you might have. They are part of the landscape that add extra information and visibility, and they're also part of an overall tool set, which we have full integrations with. We again advocate the importance of having a dialogue around the total toolset necessary to run production. Generally, you don't have to have inside the app monitoring, but if you do, you should be bringing in the data into things like, say, for example, a capacity planning tool. And we have in many occasions bring data from various tools into our capacity planning tool based on that data for analytics on hotspots or cold spots. Over the last 2 to 3 years, we see a big change for FSI or more common non-regulated industries, an expansion into cloud. We have integration with cloud tools to watch the cloud platforms. For example, Amazon, Stackdriver, and Azure up there. There are also up and coming urgent new requirements such as orchestration software. As people move their apps or write other apps in containers, spinning them up, managing them, watching for failures, increasing capacity. Whilst all this can be done by humans, there's software that can manage this. And we are a part of this dynamic orchestration platform. Obviously, metrics collected in a particular way, often fast-moving metrics based on spinning up and shutting down in short windows, is very important in terms of understanding that technology landscape. So we need to be a first-order citizen to observe and monitor in this highly dynamic environment. So as you monitor this entire landscape, the key thing is that you can't make these silos. If you have 5, 6, 7 tools and they're not integrated, and more importantly, if they're not storing their data in a central repository, you're not going to understand what's going on in your production tool set. So for example, whether you're doing an RCA, having to go through the databases of each of these tools, or whether you're trying to do a capacity model or some other analytics, if you haven't brought your data together, you find it very difficult to get a detailed understanding of how your production estate works. So whilst no single tool is a silver bullet, it is really about aggregating the data for the particular task you're doing. Having log files and all the other metric data you might want to bring together into repository is also paramount. So they're available for analytics, right, later on, and reporting to regulatory concerns. Then what is important next is, the question of what am I going to be watching, right? There are many command centers, which you've seen. Many people will spin up 6 to 8 consoles and have different people watching different consoles. Problem here is network don't care about application don't care about infrastructure, and so on and so forth. But if you're the business service manager, you'd want to know where my main console is. Answering the question, how will I know if any of my applications are running slow or if my user experience is appalling? In real time, that would be your monitor of monitors. And then finally, last but not least, for your escalations or incident management or events management, that you want some sort of a service management tool. And we integrate with, key service management players that are quite prevalent these days. So as a quick summary on this production tools landscape, it is really about integration of our tools with each other, and also with other third-party tools and software you need to run production. In fact, today's talk will focus on synthetic monitoring as we started the webinar. And I will hand it over to Troy to talk a little bit about Apica. Troy.
Great, thanks, David. So I'll just give a quick, in a nutshell, description of what Apica is and how we fit into this landscape. So Apica is a 14-year-old company. We have offices in North America and Europe, focused in Stockholm, Los Angeles, New York, and London. We have over 300 customers across all major verticals with a slight focus on financials, retail, and entertainment. And we have two main products, synthetic monitoring, which is what we'll talk about today, and load testing. We've been referenced in Gartner and are one of the our leading products in both of our product lines. And we definitely value all of our partnerships, which include ITRS, AppDynamics, ServiceNow, Akamai, Amazon, and Rackspace. So just a very quick snapshot of kind of our infrastructure. So we are present in terms of being able to produce load or to do synthetic monitoring. We can do that from over 60 countries and over 100 locations. We produce some of the largest amount of load in the world in terms of load tests, and we run a very significant amount of monitors in terms of actually doing monitoring against applications. And you can see at the time of this slide, I believe it was about 300,000 checks per hour running externally against our customers' applications. And we have about 2,600 network nodes worldwide. But I don't want to miss out on explaining that also, in addition to being able to monitor from the internet against external facing applications, we also have a robust solution for monitoring internal applications, or to allow you to host your synthetic monitoring solutions within your data center to monitor those applications that are either behind a firewall or sensitive enough that you don't want to monitor them from an internet node. So we're very, very flexible in how we're able to monitor. We'll go into a little bit more about what synthetic monitoring is and what that value is later in the presentation.
Thank you, Troy. So yeah, back over to me, and just to frame why synthetic monitoring is important to service level management and agreements. Let's talk a little bit about operational resilience. So PricewaterhouseCoopers and Ernst & Young, have pegged operational resilience as essential in managing the reputation risk of technology-dependent banks. Here are some stats, right, highlighting the importance of operational resilience and how they're viewed by the regulators, at the moment mostly UK regulators, to be of equal importance, to financial resilience and what it takes to have a resilient environment. There are 4 pillars of success to operational resilience, including testing, resilient architecture, monitoring and analytics, and change management. And the key to achieving this success is finding the right balance of all these disciplines through good practices, management, and governance. More details obviously can be found, in the papers written around operational resilience by PwC or Ernst & Young. So, you can do just a quick Google search on operational resilience, white papers, and you come up with quite a number of different resources. So then you may be asking, right, where would operational resilience be applied? What are the use cases, their risks, what are their benefits? This next slide here aims to summarize the key themes within sort of more mature technology environments that operations officers, as well as the higher ups and senior management should, areas that where they should be exercising due care. Industries and businesses exhibiting high frequency, low latency, and disruptive attributes are constantly 24/7 exposed to the risks outlined here. If managed, governed, and mitigated well, will help with both, sort of saving and making money KPIs. So some examples here in blue are, whether you're an algo trader, depending heavily on the performance of the service and applications that run your algorithms. You've got commercial and retail payment services and gateways trying to cope with more than 1,000+ transactions per second. For example, Visa claims being able to handle up to 1,700 transactions per second, which is sort of equivalent to 147 million transactions per day. So it's a very high frequency environment. Another example would be programmatic media buying, marketing and advertising. It's much like algo trading, where algorithms make purchase and sale of advertising space can be made in real time. You've got examples of low latency market data or data providers to meet SLAs and to keep up with competitors. You've got, CDNs trying to meet streaming SLAs, right? Video streams or content streams. And even in sort of betting environments, right? In-play odd changes or betting, during big matches, for example. So the key takeaway here really is whilst other areas outside of the financial services industry may not have the same level of consequential regulatory jeopardy, the value that all industries and businesses derive from governing, managing, and monitoring their high-tech environments robustly is really around protecting their revenues and ensuring competitive advantage. You see here that SLAs, not meeting SLA is highlighted, and it's really a tee up to my co-speaker Troy, to deep dive on this topic in our webinar today. Troy.
Thanks, David. So so like David said, I'm going to go a little bit deeper into SLA agreements and how that relates back to monitoring and how synthetic monitoring can help in this area. So just to kind of recap where we are in terms of the agenda, we've done introductions. We've talked a little bit about both of our companies, and David went over operational resilience. And now we're going to focus in on SLA and how that relates back to the operational resilience that David talked about. So we'll talk about what an SLA agreement is, what the best metrics to use to measure SLAs are, how to handle service hour and maintenance windows, and how to use synthetic monitoring specifically to provide SLA compliance. And at the end, we'll have a little bit of time to summarize. So first thing is SLAs. A lot of you probably have only heard SLA, but there's actually two topics to cover when you're talking about SLAs, and that's the service level agreement and a service level objective. So most people kind of squash those two things together, but it is kind of useful to separate those into their component parts to explain what they are. So specifically, a service level agreement is actually the contract that you have between two parties. So if you can think of stakeholders in an application, both the users and the providers of that application, or potentially some third party that depends on that application. You'll typically have some form of agreement that where you've come to agree what it means for that application to be available and what it means for it to be useful for everybody involved, for those stakeholders. So that agreement of what application we're talking about and how much uptime is required of that application and what the repercussions are for each party, or what the conditions or the penalties it will be if that application doesn't meet those doesn't meet those levels, is what the service level agreement is. Now, when it comes to now you've agreed what amount of time the application needs to be available and what would be considered a breach of that agreement, you need a way to be able to measure that you are in compliance with that agreement. And that's where service level objectives come in. The objectives are the actual metrics or measurements that you're doing to actually determine whether or not you're meeting the service level agreement that you've entered into. So we'll talk about a little bit why it can be useful to separate those two things. A lot of times, even inside the products themselves, you'll just see SLA. But again, the SLA is determined, in other words, whether or not you're in compliance with a service level agreement is determined by whether or not you're hitting certain levels on the service level objectives that you've put into place. So, for example, you could say that a service level agreement is for 99.5% uptime of an application. But then how do you define what that uptime is? So that's where you have to go a little bit deeper and then say that the service level objective in that case would be a 99.5% successful metric against some kind of measurement that you're doing against the application to prove that it's up. So that's another kind of conversation you need to have to be able to determine those type of metrics. So we'll talk a little bit more about that to kind of define even more these two concepts of service level agreement and service level objective. There's really two cycles that you can think of when you're determining these. So this would be between any two entities that are either providing or using an application. So the first cycle on the left here, you can see we're kind of going through a negotiate, agreement, and understanding phase, and it continues to cycle there, where you try to understand what application, again, you're talking about how much uptime is required of that application, and what the repercussions to any individual, to any entity that doesn't meet that agreement would face. And on the other side, on the right-hand side, you're looking at the actual measurements. So you'll first agree on the applications and the level of uptime that you require for the application, and then you'll go into the second cycle and figure out what metrics can actually determine that uptime, and how you'll measure those metrics, and that all parties agree that those are the appropriate metrics to use. So you really have to think about both of the service level agreement and the service level objective, and you go through a cycle of agreement and negotiation and monitoring improvement on both sides to be able to create a successful and useful service level agreement that's backed up by the service level objectives that you decide on. So when it comes to the service level agreement, the number one thing that is usually being determined is the downtime of the application. So the first thing you need to do, the kind of building block or the foundation stone, if you will, that you're working from is, what is downtime? So once you come to an agreement on that, then you can work up from there. So downtime usually can be categorized into several different categories or types. You could say that it's no reply at all from the server. So I think most people could agree that at least at a minimum, if you can't access the application at all, if you can't even get it to a login screen or a landing page, then that definitely would mean that the application is down. But typically, there are less severe problems with the application that would still be considered downtime. So you can think of, you might be able to log in, but then the next screen doesn't show up, or you're able to get into the application, but certain functions just don't work. Or you're able to get to the login screen, but you type in your username and password, and it says that your username and password is invalid, even though you know you have a legitimate account. So that would be an authentication problem. Could also be considered a service down incident. So again, agreeing on all of these things, on the definition, kind of the specific exact definition of what it means for the application to be down, is important as the foundation stone for building up to a useful service level agreement. And then behind all of those agreed upon points are going to be service level objectives that determine whether or not you're meeting those conditions. So where synthetic monitoring comes into play is, so first let's talk about a very quick definition of synthetic monitoring. Synthetic monitoring you can think of as external access to your application, kind of robots or agents that access your application externally. And externally in this case just means outside of the application stack, so it still could be behind your firewall, but it's something that acts as a user, but is scripted like a robot to hit your application and to check various things. So it could do something as simple as just checking the start page to verify that it responds. It can also access the application as a user and check the functionality. And depending on the complexity level of the service level objectives that you're trying to measure, this could be full user journeys with multiple steps going through. So one example here that we have on the slide is making a reservation inside of a travel agent site or something like that. You could actually go through the process, and if you're able to successfully go through that user path, we would consider that a success. If it fails at any point in there, then that would be obviously a failure, and would roll back through the service level objective and affect the SLA. In addition to monitoring the application itself, sometimes it's very important or very useful to measure the APIs that back up the application as well. So if your definition of downtime for the application includes the API, then you'd want to have measurements for that as well. In addition to simply the application being down, there are also situations where you may also either be forced to include the concept of the service not being usable, or you may want to track that on your own. So in addition to something like the application just not being available, or the functionality not working as expected, or the APIs not responding as you'd expect, you may also have situations where the application is technically functioning. You're able to get to it, you're able to use it, but the amount of time that it takes to do certain functionality is beyond what is acceptable to your users. So again, the application is technically working, but is not within the reasonable bounds of what would be expected from a performance standpoint. And that may still be something that you want to define, or that a stakeholder involved in the service level agreement may want to define as service not usable, and in that sense, still considered down from the agreement's standpoint. So examples in here are that you could end up using an application where you're able to add a product to the cart, you're able to check out, but it takes 45 seconds per step. If you're a sales organization or an e-commerce site, then 45 seconds to produce or to achieve each of these transactions may end up being unacceptable to your users and may lead to churn and a hit to the reputation of your company. So that would definitely be something you may want to consider in the service level agreement, or stakeholders may want to do. In addition to uptime and downtime, it's also important to take into account the maintenance windows. So not all applications need to be available 24/7. So if you do have an application, for instance, a business productivity application or something else which does have business hours, it's important that you take those into consideration both in the agreement and within the measuring tool that you're using to confirm that. So in your agreement, you'll want to understand what the business hours that you as the provider of an application are held to. And then inside of the monitoring tool, once you've determined which metrics or which measurement style you're going to use to measure the availability of that application, you'll want to exclude non-business hours from the measurements, so that you're not being docked against your SLOs or SLAs during hours that the application is not required to be available. You may also want to include times that your ops team or your development teams or anybody else who has the ability to deploy that application or work on that application or the infrastructure, you may have designated times that they're allowed to work on those, and you'll want to have those excluded in both the contract and in your monitoring as well, to make sure that you're not being docked for time that you are technically allowed to and need to work on the maintenance and improvement of your application. So the best metrics for SLAs should always, especially from the point of a service level agreement, should match with user perception, because that's technically, if you're a stakeholder in an application or a provider of an application, that's the bar that you should be held to, is what are the consumers of my application or the users of my application experiencing when they're coming to look at the application. So you want to look at measurement styles. When you look at service level of objectives that are going to back up your service level agreement, you want to look at metrics and measurements that will conform to and match with what the user would see. So you're going to look at measurements that show user perception of the service. You're going to look at metrics that can show whether the service is fully functional, and you're going to show also if there are partial degradation. So this comes again back to that performance point. So sometimes the application can be technically available, but not usable from a user's perception point of view. And you want to be able to capture those partial degradations that cause problems with your users as well. So how do we do this? So we've kind of defined what a service level agreement is. We've talked briefly about the fact that you need to back up service level agreements with service level of objectives, which are the things that you actually measure to determine if you're meeting your SLAs. How do you use synthetic monitoring to work with service level agreements to do this? So synthetic monitoring, the main point to take away with synthetic monitoring, again, we've talked about how it's kind of robotically scripted agents accessing your application from the point of view of a user. The main thing you should take away about synthetic monitoring is consistency. It's all about running the same thing, the same type of script, so the same actions against your application from the same place with consistent timing over the entire time that your application's needed or contractually obligated to be available. So synthetic monitoring provides you the ability to run performance monitoring or functionality monitoring 24/7 and generate traffic that's very similar to what your users would generate. You can do that from predetermined locations inside or outside your firewall, and they measure real application usage. So this is, again, gives you that point of view that the users would see when they're actually accessing your application. So again, number one thing to take away from synthetic monitoring is consistency, which is key for getting accurate measurements that relate to service level agreements. There are 3 dimensions of synthetic monitoring. When you set up synthetic monitoring, you can really expect to get an answer to one of 3 questions. Is the application available? That goes back to you're simply able to get to the application and either just kind of get to the login screen or get to the first page, and you're getting at least minimal accessibility to the application. So that would be an availability question. Then you can answer the question of how performant is the application. So is it able to load in an acceptable amount of time? Is it able to do certain functions within a certain amount of time? And the third question you can answer is functionality. Are we able to do certain functions that are expected of the application? Can we complete a transaction as expected? Can we perform all of the critical path type of operations that the application is required to do? The types of applications you can monitor are pretty much anything that's internet-based. So most modern applications, whether those be website-based, which are kind of the core applications that you see out in the world, deployed in the world today, whether those are productivity apps or e-commerce apps or financial trading applications, almost all of these are primarily web-based applications today, and certainly synthetic monitoring and Apica solution can help you with any of those. They're also very heavily API-driven applications, which certainly Apica solution can help with. And we can also help with legacy or thick clients. So if you have something that needs to be installed on your desktop and connects up to the network, but is actually an installed application, we can help with that as well. So you're looking at pretty much any type of application that accesses or works over a network, whether that's internal or external, being able to measure both the kind of UI experience, so being able to script clicks and typing onto a web page, logging into your application and walking through it as a user would, or scripting against your APIs, making certain API calls and ensuring that the response that comes back from those API calls is what you're expecting. We also can help with streaming services, Internet of Things devices, web platforms, really any kind of application that, again, is delivered over the network. So you're not going to be left out in the cold no matter what kind of application you have, as long as it is primarily served over a network. When it comes to a monitoring solution that can support SLAs, you're really going to look to have these kind of points satisfied by the solution. So of course, you need to be able to show those SLAs and KPI metrics in the solution itself. So either in the portal or in generated reports. You need to see uptime reports that will show you the comparison of uptime to downtime of the application. So you can kind of look at that in more detail. You need to see incident alerting. So you need to both in the system itself and also through emails or SMS or through webhooks to other solutions like ITRS's solutions to be able to see when incidents that break thresholds occur. You need to be able to look at the performance of your application from a performance standpoint over time, so you can see if there are trends in how your application is performing. You need to be able to look at a proactive uptime analysis to kind of predict whether or not you're looking at problems in the future. And you need to be able to understand release quality data. So if you do new releases of your application, what is the impact on the quality of the delivery of that product? So this is really the kind of points that you're looking at in a synthetic monitoring solution or in any kind of monitoring solution that you're hoping to use to back up your service level agreements. To break that down into kind of a matrix here, there's when we're talking about the vast majority of applications on the market today or that are being monitored today, they really can fit into one of these 4 quadrants. And on the rows are broken down into is it browser-based or is it an API-based monitoring that you're looking at doing? So is this a web-based application or are we looking at accessing the APIs that drive either a thick client or simply a computer-to-computer system level application? And then on the columns, you've either got single transactions, we're calling it single page here, or multiple actions. So are we just testing one specific thing, or are we testing more of a scenario or journey? So you can look at, if you're looking at a browser-based application and you only need to test a single page, then you can basically just do a single page load in a browser and you'll be fine. So that would be, again, testing something like the login page to your application or just a simple marketing page or something else like that. If you needed to actually log into the application and go through a critical path, then you have a user journey attached to a browser check. attached to a browser monitoring. If you needed to do multiple actions in the browser context, then you could just use a user journey, which is basically a script or a scenario attached to a browser that allows the monitoring to walk through your application as a user would use your application. On the API side, you can do simple single requests to your API and verify that what we get back is correct. So this is more on the availability side, but it allows you to check both that the API is responding and also to verify the response it gets back. In a lot of cases, you'll see that the API actually will be used in kind of a chained fashion. So it's not a single API call that you're worried about, but actually making multiple API calls in a row, and that all of those will add up to a successful transaction. So in that case, we have special scenarios using a proprietary tool called ZebraTester that allows you to build complex scripted API transactions to verify that your API is working not just in single calls, but across multiple calls. So this matrix really, again, it doesn't cover every scenario that you'll see, but in the vast majority of applications out there, one of these quadrants will, or if you're able to check off all 4 of these quadrants for your larger applications, then you'll have very good coverage of your application and be able to see exactly what's going on. Another kind of concept that I want to bring up when it comes to monitoring service level agreements is it's very difficult to monitor real applications out there in the world as a single object. So there's not one monitoring check or one monitoring solution or kind of point system that you can put in place that's going to give you a complete picture of what's going on. So what it helps to do is to divide your application into smaller pieces and monitor each of those separately. So synthetic monitoring is a great fit when it comes to specifically monitoring service level agreements, as well as getting your own insight into your application. However, it still makes sense to look at your application not as a monolith, but as individual components that you can measure. So different things that you can do there are to create scripts for the high-level user journeys. So if you can think about you'll hear the word critical path thrown out a lot, which just means if you look at your application from a user perspective, there's going to be certain paths that are more important or more prevalent from a user perspective. And those are going to be the ones that you're going to want to identify and then monitor. So again, breaking that application, not creating a single script that touches everything in your application, but creating several scripts that look at each of those user journeys and measure them independently so that you can see that different paths through your application are working or are having problems. Same thing with your APIs. If you can break your APIs into the more critical APIs and the ones that have a higher frequency of usage, and then monitor those independently, then you can really understand not just a single SLA for your entire API, but look at individual components of the API and how those are performing. And you want to look at not just covering your own application, but most applications today also depend on external systems. Either internally you're going to have multiple departments that are delivering microservices or dependencies to your core application, or you could be looking at third-party vendors that are dependencies to your application, and you're going to want to monitor those as well. So that'll help you both to understand when external vendors can cause issues with your own application, but it can also help you when you're defending your own SLAs. So understanding when third parties are impacting your SLAs to down the line stakeholders to your application. And one more thing to think about when it comes to service level agreements and breaking it down into the smaller pieces is you really want to break those pieces down in a way that align with how your users think about the application. So when you look at those sub pieces of the application that you're applying monitoring to, if each of those sub functions show up as green or successful in terms of the monitoring, does that line up perfectly with how your users will think about the performance of the application or the availability of that application? And if you do that well, then you can also get a better look into whether or not there's partial degradation. So that's where, again, if the application is really functioning the way you expect it to function from a technical standpoint, but isn't meeting user perception in terms of being a useful application. So if you have broken your application into sub-functions well that line up with how your users perceive the application, then you can set proper thresholding to show partial degradation easier down the line. So bringing it all together, if you look at the measurements that you're applying, so if you think about now you've understood from a contractual standpoint what it is that you're trying to achieve. We've agreed what uptime is in terms of your application. We've put some thought into what type of monitoring or what type of metrics we want to apply to the application to determine that we have met the contractual obligations for uptime for that application. Then what you want to do is you want to bring it all together in some way to understand how that looks for the different components. So if you look at the rows, you're looking at a very simplistic breakdown of a single application. So you can see we're looking at a particular web application. We can see the booking status for that application. We can see the start page for that application. We can see the logon operation for that application, and then we can see the mobile app in terms of, and that's probably going to be the API utilization for this application. So then on the columns here, you can see the user journeys, some page checking, some API monitoring, and some basic network monitoring. So in this case, you have a very clean grid. Some of these, not all of the columns are going to be applicable to every component. So you can see there are gray sections here where we're not monitoring for that particular component in that particular area. But in general, you can very quickly sweep across this and see that that if things are functioning properly and where you need to focus your efforts in terms of getting the application back to good. And also you can see where you may be violating your service level agreements. And in this particular case, you could do this on a time base. So we could, as the example here would be, this could be for the current month, a dashboard showing you that you've met your SLAs for all of these components except for the user journeys for the mobile application and the APIs for the mobile application. So this would be a very quick way for you to have a post-mortem or to agree upon with your stakeholders which things you've met and which things you have not. And very quickly, so I'm going to lead you through a few screenshots of Apica's solution so you can see exactly how this is delivered from an Apica synthetic monitoring standpoint. First up here, we can see the dashboard. So this is showing you a bunch of different monitoring that's been set up against a bunch of different applications. You can see that we're grouping those together so you have easy access to look at different sections of different applications. You can see very quickly which components are up, which components are down, and individual SLA measurements for each of those components, which roll down into each of the subgroups. You can see for each subgroup what the compound SLA for each of those groups is. So again, that allows you a lot of flexibility to both break your application into those smaller pieces we talked about earlier, and then see both individual SLAs for individual components that you're monitoring or individual pieces of your application, along with SLAs that roll down to multiple components combined together. This is a drill down onto a single monitor. So we're now looking at the performance of this particular metric over time. So this is a ticket checkout. So this is a scenario in this case. So we're looking at the overall performance of a scenario, and you can see that there were several failures over this time period. You can see an SLA graph on the lower left-hand side, showing you exactly for each day what percentage of the time the application was available and what percentage it was down. So it gives you some very quick information on a single component, which you can then basically manipulate the timeframes and drill down on any one of those points. So if you see a failure point on this graph, you can click on that, and that's going to allow you to drill down to an individual result, which looks like this. And that's going to allow you to see basically the metrics that have to do with that particular run of that particular monitor. So now you can see the steps in this case. So page 1, 2, 3, 4, 5, how long it took for each of those, along with detailed breakdowns underneath that, showing you individual URLs. So you're able to drill down very quickly from the top level, looking at the original dashboard, seeing that there is a problem, going down to look at an individual component to see how that's performing over time, and then getting down to individual results to start to diagnose any problems there. So really understanding an SLA from a very high level, and then being able to get down and to the very, very detailed level to understand where you could allocate resources to either improve the application or rectify an incident that's happened. In addition, it's also useful to be able to collect metrics together. So having a particular place in the system where you can combine multiple metrics together and then save that as a report or send it out on a recurring basis. So in this case, what we've done is we've looked at the individual response times for different pages on a single monitor. So we have a single demo application with 6 steps, and we're looking at the individual response times for each step. And this metric or this view could be then saved and sent out on a recurring basis to anybody who wanted to see it. You can also basically look at kind of a heat map over time to see if there's issues happening in your system. So this helps you to quickly look at the kind of historical performance of your system in terms of incidents. So now if you wanted to focus in on particular applications or particular groups of applications or particular components within your application, you can use the filter bar at the top there to focus in and look at it from a more heat map perspective, what type of incidents you may be having in your application. And then being able to combine all of this together to pull it together into reports that you can then send out to the stakeholders to help show exactly how the application is done over time in more of a report fashion. So there's multiple reports that are available to be able to show both the SLA and the overall performance of individual or multiple applications as are needed. And with that, I'll pass it back to David.
Thank you, Troy. Thank you very much, for that excellent deep dive and demo into the SLAs and SLOs and how Apica manages them for clients. So, just to bring Troy's presentation, together, we thought it'd be a good idea to share a real-life use case to highlight the importance of synthetic and real-time monitoring to back your SLAs and SLOs. So this use case, in fact, is a regulatory mandate for one of our existing FSI, financial services clients. In fact, they're a bank, and it's really a more complex, type of API call using a deployed smart card and card reader to facilitate a secure application login process for the banking company customers. In fact, that was a key success criteria for that bank itself. Deploying, Apica, it ensured the security of the login checks by integrating with the bank's existing security solution. I can't really name that, but most banking, sort of companies will have their own sort of security solutions, and in a nutshell, the banking company is now running a hybrid on-premise solution as well as cloud, access, because of its high security requirements. So that was a real sort of use case, and the quick snippet of this is that it's a hybrid environment, right? And it's well architected and integrated. Only Apica was able to deliver this sort of hybrid environment where it was both on-prem and also reporting into the cloud. For example, Apica's private agents installed in this banking company's data centers will use connected smart cards as a starting point, to run the authentications and then monitor user journeys, and at the same time reporting this back to the Apica SaaS portal, where alerts and incidents will then be sent through to Genios, ITRS Genios, because this existing client was also using Genios, as well as integrating with ServiceNow for incident management and escalations, respectively. So it met the regulatory mandates, and one of the key sort of KPIs, right? And also another sort of snippet is that they sort of highlighted their confidence that, their applications are performing, to handle this kind of secure login service moving forward. So this basically concludes our webinar. I hope you managed to take away more than a snippet. And please contact either ITRS or Apica and help us share this with your network. Thank you for your time and listening to the both of us.